Okay, good afternoon, everyone. Thank you for joining us today. We only have a couple people on right now. It looks like we have Daniel Roper, Lara Tremore Spears, Teresa Connor, and Tim Stevens. Hopefully we'll get a few more come on as we progress, but we appreciate you showing up this afternoon, and we're actually approaching the end of the Thrust B series and are excited to learn more about coastal flooding with a presentation from the UN Director, Dr. Mazdak Arabi. So Thrust B focuses on innovation and technological solutions using the data, models, and enhanced process understanding developed under Thrust A. A variety of solutions are explored under Thrust B, including building to community-scale resource recovery and reuse systems, green infrastructure, sustainable urban drainage networks, and resilient floodplains. Our webinar schedule and details are posted on the UN calendar, which can be accessed from the main menu of the UN website. We will continue to record each webinar and post them to our YouTube channel, and as always, a link to the video will be distributed as soon as it's available. Quick reminder, you have entered muted, so please use the questions, or please put your questions in the chat queue. I'll be monitoring those throughout the presentation, and we will address them at the end. So please be sure to join us next week when our Thrust B series concludes with a presentation from Dr. Sybil Charvel on the impacts of urban growth and climate change on water demand. Dr. Charvel is also presenting a webinar tomorrow, Friday, September 1st, on gray water reuse. This webinar is actually hosted by the CSU Extension Office, and the details for joining the presentation are also available on the UN website calendar. And with that, I'm excited to introduce our presenter for today, Dr. Mazdak Arabi at Colorado State University. Dr. Arabi is the Borland Endowment Professor of Water Resources in the Civil and Environmental Engineering Department, where he serves as the Director of CSU's One Water Solutions Institute. His research, educational, and engagement activities are primarily focused on the development of decision support systems for sustainable management of water resources. He's the principal inventor for the Environmental Resource Assessment and Management System, ERAMS, a cloud computing technology for integration of location-based information with simulation models of food, water, and energy systems. Dr. Arabi also serves as the director of several major research programs, including the NSF Urban Water Innovation Network, the Environmental Protection Agency's Center for Comprehensive, Optimal, and Effective Abatement of Nutrients, also known as the CLEAN Center, and the Water Sustainability and Climate Center.
Thank you very much. First, good afternoon to all of you. I'm very excited to present some of the research findings of our flood risk analysis for assets in the coastal communities. This is a work that is being conducted by Mahshid Ghanbari, the PhD candidate at Colorado State University in the Department of Civil and Environmental Engineering. So most of the methods and results that will be presented are really the work that Mahshid has done. I hope that this will motivate you to ask questions or provide suggestions by the end of the webinar in a way that essentially allows us to build on the studies that we've done with the other works that are being conducted in Thrust B or other thrusts of the UN network in a way that we can combine some of our efforts to leverage some of the products that we have produced or others have produced at other locations and institutions to benefit from the work we are doing. I know there is a meeting, upcoming meeting at the University of Georgia for folks who are working on urban hydrology and urban flood control and issues related to these topics that has been organized by Dr. Brian Bledsoe at the University of Georgia, and many of the folks working on these projects are attending. So if I know Tim is also on the call right now, so if we could perhaps discuss some of those considerations and upcoming meeting topics would be also good to let the rest of the UN team know. So Sarah, do you see my slides?
Yep, I can see your slides and hear you just fine.
Excellent. Thank you very much. So obviously, you know, the topic of flood risk assessment and responding to flooding events right now, it's a very sensitive issue because of the floods that are happening in southeastern Texas and Houston area, devastating floods, and for everybody, and in particular the UN members that live in that area and work at Texas A&M and other institutions in that region, our thoughts and prayers are with you, and hopefully the recovery is fast. And if there is anything that we can do, obviously we would love to participate in helping anybody, and in particular the Yuban family. So I just took a couple of screenshots of the news articles appearing in New York Times and Washington Post this morning, showing that the most recent study coming out of University of Wisconsin shows that these events that are happening are unprecedented, not observed before, and perhaps 100 years or more return period events, as you can see on the picture on the right panel. And then the socioeconomic impacts and impacts on human health and risk to human lives has been absolutely tremendous. It's been truly devastating effects. The events and the effects have been really devastating to cope with. So, as we discussed, the flood risk and flood risk assessment and what's happening with the climatic events, what triggers this type of events, storm surge. And there have been a lot of recent publications in response to these events with regard to upstream land use, land cover, urbanization, growth patterns, and combined effects of heavy rainfalls and storm surge that cause some of these events that can be considered in the works that all of us are doing. These images that you see here, the top left panel shows I-10 east of Houston, and in southeastern Texas just yesterday, that shows the highway essentially looks like an ocean. And these events are happening with more frequency, and whether this is due to natural cycles and natural precipitation cycles and extreme events, or how we can kind of apportion some of these effects and circumstances because of climate change or land use land cover and population growth. And these are things that again are obviously very important for flood control. In addition to storm surge and heavy precipitation, tidal flooding in coastal regions have become a more serious challenge to coastal communities because of sea level rise. And if sea level rise continues with the rate and pace that it has been increasing over the course of past couple of decades, many cities and municipalities and regions like Miami region will essentially be underwater unless some substantial adaptation and mitigation efforts are put in place. So I thought also maybe I share this slide with you that the work that was done and published in Nature Climate Change 2015 that shows the risk to coastal communities throughout the world, and in particular in areas like Miami, where tremendous amounts of assets and human lives are at risk due to coastal flooding. So some of these areas include Miami, New York City, New Orleans, and obviously with the recent events that are happening in Houston, all of the coastal regions in Gulf of Mexico and eastern shores of the United States appear to be in great danger and under significant threats due to this type of events. So in general, the principal types of flooding that folks look at include riverine and channel flooding, urban flooding, coastal flooding, and then this concept of compound flooding, the co-occurrence of heavy rainfall events that cause riverine and urban flooding, combined with storm surge that could actually really exacerbate the situation substantially, are types of events that have been studied over the course of many decades, and compound flooding over the course of past few years. Many of our Trust B researchers, as I mentioned, Jim Smith at Princeton and Andy Miller and Brian Bledsoe at University of Maryland, Baltimore County, and University of Georgia, and their students are working on a lot of topics around heavy rainfall events, and precipitation events that trigger riverine and urban flooding. Modeling systems that can be used to analyze and assess risk to these events. And one of the really interesting topics that Brian's group is looking at is obviously a probabilistic, stochastic characterization of floodplains and inundation maps that can be put together when we assess risk to communities and populations and assets when we do river and urban flooding. Our focus for this particular study is on coastal flooding as a complementary study that could be used for enhancing our understanding of how changes in climate and sea level rise and other socioeconomic factors influence the risk to populations and communities throughout the coastal regions across the United States. So I also wanted to share some information from the National Weather Service where they identify minor, moderate, major, and record flooding. To just give you an idea, at least for river flooding, the understanding is that for floods less than 15 inches of floods with depth less than 15 inches, those are categorized under minor flooding. 15 inches to a couple of feet of flood depth is usually characterized as moderate, and above 2 feet of flood depth, that's usually major. And obviously, again, in circumstances like what we are observing now for Houston and Southeast Texas, those are record flooding that have never been observed before. For coastal flooding, we have looked at two types of events that cause flooding. One is tidal flooding. These are lower consequence, lower flood depth water levels that cause perhaps smaller amounts of damage, but they are more repetitive. And as sea level rises and has risen over the past decades in many regions throughout the world, these tidal floodings, although their consequences are perhaps smaller than storm surge, but since they are more frequent, estimated losses from these events are substantial or could be substantial. And on the right-hand side, you see storm surge flooding, perhaps in response to hurricane events like Hurricane Sandy or Katrina or Hurricane Harvey that we are experiencing right now. These pose acute hazards with substantial consequences, but obviously the frequency of these events is much smaller than the frequency of tidal flooding. In the very traditional context of risk assessment, we characterize risk as likelihood of an event or likelihood of failure or likelihood of a flooding event in this case times the consequences of those events. So again, if the consequences are not significant, but an event occurs more repetitive, these are characterized under chronic type risks and could over a longer time period pose significant damages and risks to communities, but also costs because of the damages to buildings and other assets in that region. And obviously, again, as I mentioned, for acute hazards like hurricane events and storm surge, the likelihood of those events are smaller, but the consequences are substantially larger than tidal events. So one of the objectives of the study is to look at the relative importance and expected annual losses due to these two types of events that could occur in coastal regions. Our objectives, essentially, the first objective that we want to do is to develop an assessment framework for assessing risk to assets and communities in coastal regions. Again, so far our focus has been on tidal flooding and storm surge, but as we go forward, we are looking at the increased frequency of compound flooding, again, the co-presence and occurrence of heavy rainfall events and rivering and urban flooding in addition to storm surge as another component of this tool. But the framework that we are presenting here is has been developed such that can incorporate again these additional considerations. So once this framework is fully developed and published and reviewed and presented to the scientific community, we have and we are going to explore the effects of sea level rise. Essentially, again, with the increasing and the rising sea levels, the frequency and damages due to occurrence of tidal and both tidal and storm surge flooding could be substantially larger than current sea level situations. And then one of the specific objectives of our study is to disaggregate the damages in space, do a spatial analysis of how we can classify damages to assets and communities by demographics, and including income and race, and also maybe by some regional analysis by county and some political boundaries that may be of interest to communities who are in charge of managing, stakeholders who are in charge of managing these assets. Our study area for the first part of our work is southeast of Florida. We have looked at the Palm Beach County, Broward County, and Miami-Dade County, as you can see in this image or in the panel on the right. This is the Miami Metropolitan Statistical Area, in again southeastern Florida, that we've used as our first case study. And as I will mention at the end of this discussion, we are going to expand this study to all of major coastal cities in the United States. In particular, in this region, because of this, tremendous amounts of assets at risk and the impacts that have been already observed for this region over the course of past couple of decades, several task forces and groups have been formed to study the impacts of climate change on sea level rise and risk assessment of the risks to the communities. So you can see some of these reports published over the course of past couple of decades. What I wanted to highlight here is that compared to a reference year of 1992, the interest and realistic scenarios that folks want to assess in this region based on these published reports is half a foot to a foot increase in sea level rise by 2030 perhaps, and then maybe 2 feet of sea level rise by 2060 is something that is of particular interest for stakeholders in the region. Again, there are several reports that summarize some of the preliminary studies that have been done, including inundation maps and some of these projections for climate change and sea level rise for the region that we have tapped into in our analysis. So to very quickly characterize our approach to assessment of the likelihood of different flooding events, we are looking at tidal flooding and storm surge flooding. To characterize the likelihood of tidal flooding, we first look at the historical water levels observed in coastal regions. There are NOAA stations and other organizations that observe sea level over time, and we have access to those information to characterize variability in water level. The second step is to define a tidal flooding threshold, essentially a level beyond which tidal flooding will occur. And then the frequency of exceedances of these thresholds are modeled by a Poisson distribution. I will refer to this again and discuss it very briefly in a couple of slides later. And then once we characterize how often tidal flooding occurs, the task is to essentially model the stochastic characteristics and the variability of, should tidal flooding occur, how much the flood threshold is exceeded. So the depth and intensity in addition to the frequency of tidal flooding. For storm surge, our analysis has focused on accessing data from FEMA flood insurance studies. There are several other studies in the region that one can tap into and benefit from. The reason that we focus on the FEMA studies is because this is the basis for insurance and claims for damages due to these events. So we've used the studies that have been done for many municipalities and various regions across the country as the basis of our analysis for likelihood of storm surge flooding. So we obtain storm surge still water elevation from FEMA studies, and then also the relationship between return period and exceedance probability of various sea level, still water elevations is obtained from the studies that are available for, again, as I mentioned, for all regions across the country, inland or coastal, but obviously in this case we are talking about the Miami MSA. For characterization of the damages, sorry for my wrong title here, we look at the damages to assets. First, we obtain building stocks and contents of these buildings, and also some basic information about roads and infrastructure in a given region from FEMA's HAZAS model. This is MH model. This is I think most of you are familiar with the HAZAS model, which provides a building stock and again the assets in any given region. And then for various inundation levels, one can estimate damages to the buildings. So in addition to exposure, we look at damages to buildings and again some basic infrastructure in various locations in our assessment area, in this case Miami MSA. And what Mashid has done, she's looked at damages caused by 10 levels of tidal depth, going from again 0 to 10 foot of flood depth by 1 foot increments, to be able to compute essentially a damage or a loss curve as a function of flood depth. And these are conducted at a census block level. So we have this data or this damage curve characterized by census block level or at census block level. All of the computations are conducted at census block level, and then they are aggregated back up to the assessment area by various methods for disaggregation and then aggregation of information. And then for socioeconomic factors, again, since we are doing our analysis at the census block level, we are able to characterize impacts at that scale by socioeconomic factors such as population, such as race and income levels. And what we do, we assume homogeneous or a uniform distribution of losses within each census block, which is perhaps a reasonable assumption. And we assume that losses are proportional to the fraction of populations within that census block, and then we again aggregate back up to our assessment area. So HAZAS model, again, to simply just refer to what HAZAS is uses digital elevation models or other terrain models that can be used to characterize ground surface elevation. Then with flood surface elevation relative to the ground surface elevation, depth of flooding is characterized, and population and properties as risks are incorporated in the analysis. Damages are calculated, and then losses are estimated based on this. Obviously, HAZAS is one of the most commonly used models for damage assessments for not only flooding events, but other natural hazards as well. So on the panel on the right, what you can see is for those 10 increments of flood levels, you can see areas that will be inundated based on this HAZAS assessment. I just want to mention here that also NOAA has a really nice website to download these inundation maps. Those are based on NOAA's techniques that are used, spatial analysis techniques that have been used to estimate these maps. But when we try to corroborate our maps with them, there's a very good corroboration between these maps that you see here, or these the block level assessment of flood inundation maps, and what NOAA has put together. There are some disagreements, but the level of agreement is very strong and very significant. The other step in our analysis, which is really important and influences substantially estimation of damages and the characterization of damages due to tidal flooding versus storm surge, is characterization of what is a tidal flood and what is storm surge flooding. So as I mentioned, there are studies and there are suggestions and recommendations by NOAA and National Weather Service for rivering flooding. And as you can see here in National Weather Service publications for coastal regions, you can see minor flooding is perhaps flooding that is low threat to property and usually between 1 to 2 foot of inundation. Moderate and major flooding are characterized by 2 to 3 foot of inundation, and greater than that is usually characterized by major flooding, as you can see here. So using this information, we characterize inundation up to 2 foot of inundation as minor flooding and tidal flooding, and above that as moderate and major flooding under storm surge classification. And if you look at the water level data for this region from some of the monitoring stations, and the tidal flooding and storm surge levels that we've considered compared to the mean high water levels. So what you can see here, the fluctuation of essentially sea levels based on this measure, which is mean high water, and our characterization of how much is tidal flooding and storm surge, they actually can be corroborated with some other studies that have been recently published in terms of even media claims and other characterization and classifications of flood into rain events, tidal events, and storm surge. And as you can see, the levels that we've considered to define tidal flooding or storm surge can be corroborated based on some of these other published efforts. So based on that, based on this analysis, tidal flooding threshold in this region is 1.31 feet above MHHW, and as you can see in this slide. And then major flooding or storm surge is above 2 feet of inundation, 2 feet above MHHW is characterized as storm surge. As I mentioned, also we have looked at sea level rise scenarios. Obviously, we are looking at current sea level, but also 0.5 foot, 1 foot, 1.5 foot feet, and 2 feet of sea level rise as scenarios considered in our analysis. We stopped at 2 feet of sea level rise for 2 major reasons. One is in the reports that I showed in the Miami area, that is the most realistic or the reasonable range of sea level rise that folks in the region are interested for their assessment, at least based on their published reports and the working groups that are working on climate change and sea level rise issues. And the other factor is that above 2 feet of sea level rise, essentially almost everywhere in the region gets flooded, and the damage is perhaps very close to exposure levels that can be estimated from our analysis. So again, sea level rise scenarios that we've studied are these 5 categories. For tidal flooding, we first obtained hourly water level data for in some of these observational locations, we have more than 5 decades of data on hourly basis, which is great and allows us to really gives us significant statistical power and enough years to be able to characterize events by return period and so on. But even 20 years of data for example, in our region, in this case, Miami MSA, is adequate perhaps to characterize the tidal activities and sea level sea level dynamics under current conditions. And then what we do again, we use a peaks over threshold method to characterize exceedances and magnitude of exceedance above the threshold for tidal flooding, and then we use a Poisson distribution to characterize the frequency of exceedances. And these two combined will allow us to characterize the likelihood of exceedance and then the magnitude or intensity of exceedance of tidal flooding above threshold. And then we have the damage curves from hazards for at block level So what essentially is done, we integrate the damages based on depth and the likelihood or the probability of those inundation depths. And then that integration between our tidal flooding threshold and inundation thresholds give us the average annual losses and estimates for tidal flooding. For water level data, as you can see here, these figures show monthly, or actually daily and sub-daily. I think these are based on 1 hour data that you can see. If you look at all of the data, very clearly we can observe daily water level data and then average behavior or mean expected behavior of these water level data in the region for the Virginia Key tidal stations shown on the right panel. So the important thing that we wanted to indicate here is that there are two important issues to consider. One is under current condition, which is the top panel on the left. Most of the tidal flooding thresholds or exceedances of tidal flooding thresholds occur in some certain months from September to December. In the rest of the year, almost we don't observe any exceedances of the tidal flooding threshold, and then you can see the exceedances of storm surge thresholds in the region. But when you look at the situation, if we assume the same tidal dynamics hold and processes hold when sea level rise happens, and if we shift all of this, this variability of water levels and add to that 1 foot of sea level, then you can see obviously the frequency of tidal flooding substantially increases due to sea level rise. So I'm not showing this here, but one can characterize the frequency and likelihood of exceedances of tidal flooding over the course of past several decades, and there is a very clear trend in increasing frequency of tidal flooding. They have been published by NOAA and other agencies that we have considered in our analysis. And there are key assumptions that, again, we've made here. First, to be able to do tidal flooding, it's as particularly as sea level rise scenarios are assessed, we get to the point that there are many exceedances of the tidal flooding threshold, and therefore the situation becomes, or we encounter situations where assuming that damages to assets and communities, the assumption of independence between these events are not reasonable and reliable anymore. For this methodology of peaks over threshold, one can estimate or come up with algorithms or logic. It could be based on published efforts or socioeconomic studies in the region to identify periods for analysis where assuming independence between tidal flooding is a reasonable assumption. So in this case, our initial studies show that a 2-month assumption is a reasonable assumption for independence of exceedances of tidal flooding thresholds and tidal flooding in general. So the way that we have characterized this, we've looked at the dynamics of tidal flooding over 2 months periods, and for these 2 months periods, we've looked at the maximum damage caused by those, and then stochastically using robust statistical and probability models, model the exceedances over those 2 months, and then computed the damages, and then we have assumed that these damages now are independent. So the point here is that as sea level rises and likelihood of occurrence of tidal flooding increases, one must take into consideration that the damages to assets in the region may not be necessarily independent, and we've done that. And this schematic shows that, under sea level rise scenarios, some high tide events and tidal flooding can become more frequent. And the top panel are assessments of the frequency of tidal flooding. As you can see, these are event rates per year or those periods specified on the bar graph, you can see that under current condition, most of the tidal flooding occurs between September and October, but as sea level rise scenarios are evaluated, we may have much more substantial occurrences and frequency of tidal flooding. So that's one important consideration. The second consideration I want to mention here is, and highlight here, is that in a lot of previous studies, people have looked at whole region assessment of impacts of flooding, coastal flooding in general, storm surge or tidal flooding, but particularly for tidal flooding, folks look at damages to assets and communities by assuming a single damage curve for the entire region. Of course, that kind of approach could be valid when we look at the entire area, like county level assessments or multi-county level assessment areas. But to be able to disaggregate impacts by socioeconomic factors, one must build these damage curves for specific block groups and then aggregate up based on the assumptions that I mentioned earlier in the presentation. So what this panel shows is that if you look at the inundation map for the Miami MSA and zoom into a specific region, what you can see here, two block groups highlighted. One is a coastal block group, or a block group right adjacent to the coast, and then an inland block group. If you look at the damage curves for these two block groups, they could be substantially different, as demonstrated in the figure in the left panel. And then when you look at the aggregated damage curve, it's usually somewhere between all of the damage curves for block groups. So the point that we wanted to highlight here is that when we characterize damages due to tidal flooding or storm surge flooding, we must consider specific damage curves for block level, for specific census blocks, and then try to aggregate those up once we characterize impacts on different socioeconomic groups. Again, in this particular case, we are interested in race and gender, and also income levels. So if you look at the demographic characteristics of these two different block groups in the region, you can see the shoreline census block, or the block just adjacent to the coastal region. You can see that the distribution of or the demographics are substantially different than the inland block group. In this particular case, in this region, most of the inland block group are, for that particular block, is Hispanic, while there is much higher population of whites in the shoreline census. Also, income levels are substantially different. Obviously, in this particular region, perhaps folks who occupy buildings on the shoreline have higher income levels. So, if you consider the diversity and discrepancy and variability of socioeconomic factors, if we assume the same damage curve for the entire region, we can get substantially misleading results if breaking down the costs and damages by socioeconomic factors is an important consideration in this study. And then finally, for a storm surge, again, we've used the flood insurance study. We obtained still water elevation, estimate losses to assets from these still water elevations from using the hazards model again, and then we relate losses and then exceedance levels for these inundation levels, and the area under the exceedance probability and corresponding losses gives us average annual losses. So average annual loss is simply the area under exceedance probability versus expected losses. So that's really the methodology that we've used for tidal flooding as well as storm surge. So let me show you some of the results to inform hopefully some meaningful conversations as we go forward. So if you look at a single tidal flooding for Miami MSA compared to storm surge, obviously for a storm surge, one can look at various storm surge levels corresponding to different return periods and exceedance probabilities. If you look at a 100-year event, storm surge compared to one single tidal flooding, as characterized by the methodology that I mentioned, the generalized Pareto distribution and Poisson distribution, we can see that a storm surge corresponding to a 100-year event could be substantially larger and more impactful than single tidal flooding in the region. And so under current condition or future sea level rise scenarios, these patterns are evident. Obviously, as sea level rises, the frequency of tidal flooding rises, and the expected damages under a single tidal flooding could be, so not only the occurrence and likelihood of and frequency of tidal flooding increases, but the depth and intensity of tidal flooding increases, and therefore you can see an increase in expected damages under a single tidal flooding as shown here. But again, single storm surge corresponding to a 100-year event substantially larger in magnitude. However, if we incorporate the fact that, or consider the fact that tidal flooding occurs much more often, particularly as sea level rise occurs, then you can see that expected losses for Miami MSA on an average annual basis could be substantially higher than storm surge, because storm surge events, of course, a single storm surge has much higher consequences, but its frequency is lower, and therefore when you integrate the tidal flooding, average annual losses due to tidal flooding could be substantially higher, particularly above 1 foot of sea level rise. So we are talking about 2030 and beyond, based on the most reliable estimates in the region. So if for practitioners and managers to consider what type of adaptation and mitigation strategies have to be put in place, perhaps some of these type of analysis it would be useful in the region. So if we break down the cost, you can see 26% of the cost is again, since we are doing the analysis based on census block level, then we can aggregate up to county level. So 65% of the cost for tidal flooding can be essentially considered that would occur for Miami-Dade County, 26% for Broward County, and the rest will be in the third county in the region. And for a storm surge, similar trends. Most of the costs in Miami-Dade County, 70%, and Broward County, about 25%. So if we look at the same information, again, the spatial resolution of the analysis is census block. So before aggregating up, we can assume again the damages within each block is proportional to the composition or socioeconomic demographics in that block group, and then use that to aggregate up to the entire assessment area. You will see that under tidal flooding, most of the damage will be in areas that are 72% for under 1 foot sea level rise scenario will be the damages that can be said that these are assets for the white population, and 23% for Hispanics, 3% Black, and so on. Storm surge, however, you'll see that you'll get a substantially different ratios between total specific socioeconomic groups to total ratio, and most of this is because storm surge influences at much higher level the inland areas and inland block groups that are mostly occupied by Hispanics in the region. So again, that's an indication, and this underlines the importance of looking at assets and socioeconomics at block level, and then having a robust statistical aggregation method as we analyze this. And finally, you can see the damages by income levels can be the same analysis can be done for income levels. So that's the study and what we've done so far. Again, we've looked at flood risk to assets and communities by socioeconomic factors for the Miami MSA area. I think we have a robust statistical and analysis framework to be able to repeat this work for and conduct this work for major coastal cities in the United States. Obviously, in particular, we're interested in UN cities, and we'll be starting from those cities, but our hope is to expand our information to all of areas where we do have the NOAA water level gauges at least, and then perhaps even use some of the information for other regions. So that's an immediate part of our study that is coming up. And then this question of compound flooding and the co-occurrence of heavy rainfall events with storm surge is of critical importance. Even a few inches of river flooding and flooding due to rainfall and precipitation events, and its compounding effects with storm surge could pose much higher impacts and damages when these two events co-occur. And we are very interested to develop or apply our framework for assessing the impacts of compound flooding. Of course, it's an extremely challenging task because not only upstream and upland processes and considerations influence the riverine flooding and urban flooding, but also the boundary conditions, the downstream conditions controlled by storm surge and coastal dynamics could substantially change the water surface profile and so on. So we are hoping to work with other team members, Andy and Brian and others, to learn how hopefully we can adequately and accurately represent these processes in our estimation of flood risk to coastal communities due to coastal flooding and compounding effects of rainfall flooding and river flooding and urban flooding with storm surge. So I think that's all we have put together for this conversation. I would be glad to answer questions if we have time.
Wonderful. Thank you, Mazdak. We do have a couple questions, one of which I think you touched on, but maybe you can elaborate a little bit more. Liz Mack is wondering, why was the block level analysis used, and does it match with FEMA data better?
Well, again, the reason that we looked at the block level data is to be able to accurately disaggregate impacts of coastal flooding by socioeconomic factors, including race and income levels. Assuming a single damage curve and exposure curve for the entire region could give us an estimate of damages for the entire region, but won't be adequate to disaggregate impacts by these factors and by specific locations within the region.
Okay, she has a couple of follow-up questions. So Liz, I'm going to try to unmute you so that you can ask directly. So see if that works.
Can you hear me?
Yeah, we can hear you.
Okay. Hi, Mazdak. I was just wondering why is this ACS data? Because I'm and it's sort of a selfish reason I'm asking this question. I know with the ACS there are these margins of errors, and they get more extreme the lower down you go. And so I understand the value in disaggregated analysis, but maybe why not like the block group or the tract, which might be an in-between way or spatial scale to deal with these sampling errors.
Yeah, and that's a great point, Liz. I think we can, again, this methodology allows us to disaggregate and aggregate back up to assessment area as we do the analysis. The main reason we looked at the block level is that assumption of proportional distribution of losses by socioeconomic factors within a block group, it's reasonable to assume that that's a valid assumption. For us, the one could say, well, that could apply to a block group as well, but that requires some level of study. So, for example, one of the things that we want to do is to look at Twitter messages and Facebook notes and calls for, due to damages to flooding, to be able to corroborate at what level of disaggregation one can come up with a much better representation of these damages and impacts by socioeconomic factors. That's a great point. I think the major step is doing the flood level mapping and inundation maps and coming up with the damage curves. Since those are done, we could look at different levels of aggregation and disaggregation. I think that's a great point.
Okay, great, thank you. Great.
Sorry, I think I cut you off, Liz. I just on.
I was just saying kudos, great presentation. Thank you.
Okay, we have a couple more questions, Mazdak. Chingwen is wondering if there's any plans to extend the study to inland and flash flooding.
Absolutely. So as I mentioned, we are going to do the analysis for all of UBIN regions. And of course, all of UBIN regions are not coastal regions. We are going to do the analysis for inland areas, including Denver, Fort Collins, and so on. And we have to essentially coordinate our efforts with the work that Brian and his team, Andy and his teams, and Jim and his teams are doing, and Tom Meixner also at University of Arizona, to be able to, as hydraulic models are developed for, sub-regions in UN cities and regions, we will apply the same methodology for characterization of risk to assets due to flooding. But in those cases, it will be urban flooding and riverine flooding, and looking at precipitation regimes, perhaps some of the products that Jim is putting together for intensity, duration, frequency, and hopefully tapping into models like HECRAX models that folks are putting together, because in hazards we can use HECRAX instead of the built-in water levels and equations that are used for estimating damages.
Great, thank you. So I'm going to try to unmute Tim, because not only does he have a question, but I know you were hoping he could just talk a little bit about the Thrust B retreat that's going to be happening in a couple weeks. So Tim, I'm going to unmute you. Let's see if this works. I don't know if you're trying to talk, but if you are, I can't hear you. Okay, well, I'll ask his question, and maybe he can get his microphone figured out in the meantime. So he says, consideration was given to the level of magnitude of sea level rise. Is there any plan to consider an increased frequency of storm surge?
So that's another great point. So, the climate change impacts is not only reflected in sea level rise, but obviously it's going to influence the storm surge dynamics and processes that influence those, including wind dynamics and so on. The FEMA model, FEMA insurance studies use the slush model with some basic probabilistic assumptions with regard to its dynamics that may or may not be influenced under future climate change scenarios. We don't have any plans to rerun the slush models, but I know that in many of these regions, coastal regions across the United States, folks are doing their own analysis of storm surge. If this information become available, we definitely would love to use those in our studies. Otherwise, we are going to assume the storm surge dynamics will remain the same, or evaluate scenarios where those assumptions are made without rerunning the new slush model or other models that people may be developing for their regions. But again, as we expand our analysis in the region, in the Miami MSA region and other regions, when there's other analysis that do look at changes in climate change or changes in the dynamics of storm surge and coastal processes due to climate change, hopefully, if they're available, we will incorporate that in our analysis.
Okay, and Tim was going to try to call in. So I've unmuted you, Tim, but it says that you are self-muted. So I don't know if your phone is muted too. Nope. Still doesn't. Still can't hear you, so I'm going to go on to the next question and leave you unmuted in the event that we can get you to plug your retreat. So Harry is wondering if there's any uncertainty analysis being conducted in the study.
Yeah, so one of the attractive features of working within the UN is that folks are looking at different aspects of flood risk and flood inundation mapping. So Tim Stevens and Brian Bledsoe and their group are looking at uncertainty in flood inundation maps and how, for example, when we talk about a 100-year event or a 5-year, 100-year event, that by itself is uncertain. So uncertainty assessment of flood inundation maps. Once we expand our analysis to some of these regions where the uncertainty in flood inundation maps corresponding to various events as characterized in return periods are developed, then we are going to evaluate consequences the way that I just mentioned and propagate forward the impact of uncertainty in the flood inundation maps in characterization of damages due to those flooding events. So the answer is absolutely. That's one of the best parts of working on projects like UN projects as a holistic team with folks working on different parts and components of this. Once those products are available in terms of uncertainty in flood inundation maps, then we will propagate those uncertainties in. So now what that means in terms of damages and impacts on various socioeconomic groups.
Great. Hey, Tim, can we hear you yet? Yeah, well, technical difficulties always get the best of me. So there hasn't been any new questions that have come through yet. So I think we could probably wrap up for the day. I'll be sure to send out a link to this once I get it posted to our YouTube channel. And please be sure to tune in next week, Thursday, for our final presentation in the Thrust series from Dr. Sybil Charvel. And she's also giving another webinar through CSU Extension tomorrow. You can find the information for that webinar on the UN calendar, which is accessible from the main menu of the UN website. So, I think we might get Tim here. Tim, can we hear you?
Yeah, can you hear me?
Yay, yeah. So real quick, why don't you give us a quick overview on your retreat that's planned for a couple weeks?
So basically there's Jim Smith and Tom Meixner's research groups, and Jim, as we kind of explained last week in the webinar, is doing the stochastic storm transposition and some urban hydrologic modeling to represent different rainfall scenarios and model those, and then that rainfall will be impacted or input onto sort of the landscape, and then Tom Meixner's group is running some hydrologic models, and so those can be input into those hydrologic models, and then we can take the output from those hydrologic models and then run them through HECRAS that models these riverine processes, and then we can look at these different aspects of urban flooding, but there's a lot of kind of in the weeds integration that needs to happen to bring all that together in a seamless and meaningful and scientifically rigorous manner. And so that was the sort of initial objective for that, and to sort of put our heads together on the different scenarios and that sort of thing, and different locations. And then it kind of, I think we're going to potentially discuss some additional collaboration and some socioeconomic impacts, and outline some kind of our steps forward and publications and that sort of thing. So essentially just lock ourselves in rooms for a couple of days and see what we can come up with.
I'm sure it'll be very fruitful. Well, Mazdak, do you have any closing remarks before we sign off?
Well, thank you for the opportunity. I appreciate it. Tim, keep us posted on the outcomes of the meeting that you guys have. As you can see, we are very interested to use some of the products coming up out of this integrated approach that all of the team members that you mentioned and the group that are going to work with each other, we are very interested in the products to be able to evaluate consequences and translate that to some sort of socioeconomic impacts for UN region. So very exciting, and keep us posted, please.
Yeah, absolutely, and great presentation today. I really enjoyed that, and it was very informative. I'd be interested as you guys move your model inland to some of the other UN regions, how we can kind of combine that with some of these probabilistic floodplain maps to look at those probabilities of risk in the future.
Yeah, and obviously we are going to focus on regions that Jim and Tom and you guys are doing in terms of precipitation and climatic modeling or event modeling to hydrologic modeling to hydraulic modeling. We are going to look at the same locations or regions, because then we can simply tap into the products that coming out of UN research and then do our analysis within this assessment framework that I just presented. So we'll coordinate with you, and we will align our regions with and time scales and time steps the way that is consistent with what you all are doing.